grade 8s, we're nearing the end of fractions, and so finally we're going to throw everything together in this topic, which is mixed operations. Now, basically, mixed operations comes down to the idea of order of work. What do you do first? Now, if I've taught anything, it's probably the fact that we don't actually like BODMAS in high school. What we prefer to do whenever we're worried about mixed operations or what do we do first, we prefer to always use this idea of terms. Now, I've probably said this about 100 times this year. The most important thing I would ever teach you is always divide into terms. So let's just quickly remind ourselves what glues a term together. Things that are multiplied, things that are divided, and things that are in a bracket. That glues factors into a term. What divides an expression into different terms, and that's a plus sign and a minus sign. Obviously, if things are inside a bracket, the bracket kind of overrides everything. So the most important thing I can probably ever say is always divide into terms. Why? Because once you've divided into terms, we basically simplify each term, and then we move from left to right. So we don't have to actually worry about what to do first, because once you've divided into terms and you've simplified each term, you basically just work from left to right then. You add and subtract from left to right. Now, there's only one extra thing that I need to add in here. When we say divide into terms, what happens if you have quite a big chunky term, and within that term you don't know what to do first? So just remember, very important, we always do brackets first within a term. So always do brackets first within a term. Okay, now I think that's enough of theory. Let's actually look at an example. So if we looked at this first example in question A, it says a half plus 3/4, which is in a bracket, multiplied by 1/10. How many terms? Well, this is one term. I do see a plus sign, so I mustn't get confused that there's a plus sign. This is inside a bracket, and so the bracket overrides that and glues that into one term. Then it's multiplied by 1/10, so it's glued to the 1/10 within the same term. So this is all one term, this entire thing. So now that it's one term, I don't actually have to worry about what to do first, other than I need to simplify this term. And within this term, I need to say, right, do I multiply by 1/10 first? What do I do? So within this term, you always simplify the bracket first. So within this term, I'm going to simplify the bracket first. So within the bracket, I'm adding. And don't forget, I can only add when I have the same lowest common denominator. So within here, I'm thinking I need an LCD. So what is the LCD of 2 and 4? It's 4, so you can either write it as one ginormous fraction if you want to, or if that doesn't work for you, you can write it as 2 fractions, both over 4. So basically the second fraction is 3/4, so I don't actually have to worry about that. But that first fraction, how do I take a denominator of 2 and make it 4? I multiply by 2, but what you do to the bottom, you do to the top, so that you're actually effectively multiplying it by 1. Now you can't leave out this multiply by 1/10, that's still there. It's just not currently doing anything. So now I can add these two together. Don't forget that when you add, you keep the denominator and you simply add the top. So 2 plus 3 is 5. Now notice I don't need a bracket anymore, because that bracket was just indicating to me to simplify the bracket first. So you can put a bracket in here, but it really doesn't do anything, so I've chosen to leave it out. And now that we have combined our bracket, I'm now simply multiplying. Now there's two ways, don't forget to multiply. The way that I prefer doing is the cross-cancelling method. So personally, I would probably prefer to say 5 goes into itself once, so 5 divided by 5 is 1, 10 divided by 5 is 2. And then I would say, don't forget, when you multiply, it's top times top, so that's 1 times 1 is 1, bottom times bottom, 1/8. Or, there's nothing wrong with actually not simplifying and simply multiplying top times top, bottom times bottom, and then simplifying. In that case, you would say 5 times 1 is 5, and 4 times 10 is 40. And now you need to simplify. And what I'd do here is I'd say, well, I'm going to divide the top by 5 and the bottom by 5, and then I'd get to 1/8. So whatever method you prefer. So what was this worked example meant to explain to us? This worked example was meant to show us that this was one ginormous term. If it's one ginormous term, the only thing I really have to worry about is first do the bracket, and then I can work from left to right. Okay, let's look at another example. Example B. First step in example B is I'm going to divide into terms, always. Every single question you probably do from now until matric, if you're simplifying, you're dividing into terms. Now this is a bracket, and so it's gluing that, and this is divided. So this is one term. So if it's one term, I don't really have to worry about which parts of the expression to do first, but I now need to simplify this term. So remember, I always simplify a bracket first. So if I simplify that bracket first, I'm going to need to get a lowest common denominator, and in this case my lowest common denominator is 7, and 1, this would be technically over 1. So I'd multiply by 7, multiply by 7, and so 7 over 7 is 1, and that makes quite a lot of sense. Now while I'm here, this is this factor, I can't call it a term because it's still part of this one term, it's a factor. The square root of 9 over 16, that's not simplified. So I almost need to, simplify that factor as well. Now don't forget, when you square root, you can square at the top and square at the bottom. So the square root of 9 is 3, and the square root of 16 is 4. And I'm still dividing. So on my next line, I'm now going to have 3/4. I'm still dividing. And finally, I can simplify this bracket, and I have the same denominator, so it's going to be over 7. And 7 minus 1 is 6. So what have we learned here? This was still one term, but I must first simplify the bracket, and because part of the sum was a root, I needed to simplify that too. Okay, now we are dividing. And how do we divide? We are multiplying, and we flip this over. Now this is technically called the reciprocal of 6 over 7. I don't think I've used that word before. Reciprocal just means the flipped over version. So don't forget, the 3 divided by 4 stays, and I'm multiplying by the reciprocal of 6 over 7. So the swapped around version. Now different ways to proceed. If you proceed with top times top, bottom times bottom, 3 times 7 is 21, bottom times bottom is 24. Or you could proceed with the cancelling version. So you could say that 3 over 4 times 7 over 6, you could say 3 divided by 3 is 1, 6 divided by 3 is 2. Then do top times top, which would be 7, bottom times bottom, which would be 8. Now, why aren't these two equal? Well, because this one you needed to divide by 3, and here you need to divide by 3, and you get exactly the same answer. So don't forget that with multiplying, either you simplify first by cross-cancelling, then top times top and bottom times bottom, or literally the other way around. You do top times top, bottom times bottom, and then simplify. Great. Onwards to another one. Right, let's have a look at this. First step in every single question we should ever do, divide into terms. It's probably the most commonly made mistake. So if I divide into terms, this is negative 1 and 1/4 multiply, so it's glued by this root plus. Now whenever I see a plus in the middle of nowhere, those are separate terms, which means this plus 5 over 6 has nothing to do with that first term, and I first need to simplify that first term. Now a couple of things going on here. Remember, I absolutely hate mixed numbers, so I'm going to convert this to an improper fraction. So 1 times 4 is 4, plus 1 is 5, so this is 5 over 4. Don't forget that that negative doesn't play a role, it just kind of hangs out the front. Now I'm multiplying by, and this second part of this term, so I'm still going to divide into terms, the second part of this term is a root. Now if you don't like roots, you can always cheat on your calculator, but the cube root of negative 8, now does it matter who this negative belongs to? It doesn't. I'm going to think of it as belonging to the 8. So the cube root of negative 8 means what multiplied by itself will give me negative 8. Now you can cheat on your calculator if you want, but that's negative 2. And the cube root of 27 is 3. Now, just because it's not liked, we don't like a multiplication sign next to a negative. And so personally, I would put a bracket around this, not for any other reason, just that we don't like two operations next to each other. Okay, now, I still have not simplified this first term. I've almost there, but I'm still not good. So I'm going to leave the dividing of the term still, and I need to simplify this multiplication. Now, the moment I look, I'm like, I don't like these signs. So what's a negative times a negative? Well, it's a positive. So I'm just going to write a plus there so you know that I've considered the signs, but I actually could not. I don't have to write that. Now, if I have a look, two options, remember, you could do cross-cancelling. I'm going to do the multiplying out version first. So 5 times 2 is 10, and 4 times 3 is 12. So that's one of the ways to do it. Or, if I write or here, you could say negative 5 over 4 times negative 2 over 3 plus 5 over 6. Now don't forget this is a separate term. So what you could do here is you could say 2 divided by 2 is 1 and 4 divided by 2 is 2. And now I would say a negative times a negative is positive. 5 times 1 is 5. 2 times 3 is 6. Now what's nice about this version is, look, they now have the same, automatically have the same lowest common denominator, and so I can simplify. Okay, if I go back to my other version, I've still got this 5/6 here, which is the separate term. However, this first term is not simplified yet. So personally, I would now simplify that by dividing by 2 and dividing by 2. You could also add them together by creating a lowest common denominator of 12. That would be fine, and you'd get exactly the same answer, but you just have to simplify it a little first. So if I simplified that 10 over 12, I would now get 5/6 plus 5/6, whatever way I did it, and 5/6 plus 5/6, you just add the numerators, so I get 10 over 6. Now that's definitely not simplified because those are both even numbers. So if I divide this by 2 and I divide this by 2, I get 5 over 3. So both of these ways, here's I wouldn't get 5 over 3 automatically. Here I'd also get 10 over 6, and I'd simplify it to 5 over 3. So just the things with fractions and most of maths is that there's always different ways to do it, and just because you do it a different way doesn't mean it's incorrect, it's just different. Now there is even a third way to do this. I could say, or what happens if I just made them both have a denominator of 12? So I multiplied this by 2 and multiplied this by 2 because I forgot to simplify. Then you'd get 10 over 12 plus 10 over 12. And that would be 20 over 12. And then this looks different, but it is actually the same thing. Because if I divide the top and the bottom by 4, you'd go back to that answer. So it's actually 3 different ways to proceed here. And whatever way makes more sense to you is best. Now, what was the whole point of question C? The whole point of question C was to show you how dividing into terms and simplifying each term is really, really important. Okay, last question. Again, divide into terms. Always, always, always. This is a particular example where most people go wrong because they don't divide into terms and they just work from left to right. Whereas if I look at this and I say a half plus, that's a new term. So plus 3.5 divide by, now divide glues a term together. So this is one term and the half is a separate term. So the half has nothing to do with this division. So if I look at that second term, first of all, I'm going to change the mixed number. So 2 times 3 is 6 plus 1 is 7. So 7 over 2. Divide by 2 times 8 is 16 plus 5 is 21 over 8. Now this is still, if I put in my, that's the end of a term, this is still a term that needs to be simplified. So when we say divide into terms, I now need to simplify each term. So I've already started on that second term by changing all those mixed numbers into improper fractions. So now I still need my half plus, now I've got to deal with this division. So I'm going to times and swap this round. And this is still 7 over 2. Remember, the first fraction doesn't change. Whatever you're dividing by changes. Right, I still have 2 terms here. So this is still got, I mustn't add the half and 7 over 2. Most people will do that. Most people will add these two together and then divide. But careful, that a half is not part of that second term. So leave the half out of it. Okay, now there's 2 different ways to proceed because there's 2 different ways to multiply. So if you do top times top, so you get 56 divided by bottoms times bottom, 42. Now I'd need to simplify that. So now I would get equals a half, and I can divide both of these, and I must just check. I can divide both by 2. I can divide both by, well, I don't know what else. So let's start dividing both by 2. Now this is why I don't particularly like this method, is because then I get stuck as to what to divide by. Because actually I can divide both of those by 7. So I can keep going. And so this method for me tends to become longer unless I remembered in the beginning what to divide by. So this actually becomes a half plus 4 over 3, I think. Okay, so what method would I prefer to do? Personally, I would prefer to do the cross-cancelling method. So especially when you get big numbers. Now what would that look like here? Don't forget this is a separate term. So what it would look like here is I would say 2 divided by 2 is 1. 8 divided by 2 is 4. 7 divided by 7 is 1. 21 divided by 7 is 3. Because then I would go straight to a half plus 4 over 3. So I suppose if here I realized that I needed to divide by 14, but it's hard to realize what goes into 56 and into 42. Okay, so now I can continue with one sum because this is the same. I'm adding. My LCD I think is 6. So I need to multiply by 2. So I multiply by 2, so I get 8. I need to multiply by 3, so I need to multiply by 3, so I get 3. And finally, 3 plus 8 is 11. 11 divided by 6. So I'm just going to draw myself an arrow over there because either way I would continue with the green. Now 11 is a prime number, so 11 divided by 6 cannot simplify. And I have my answer. So this question was all about dividing into terms, simplify each term, and then add from left to right. Now hopefully these 4 examples pretty much cover everything that you need to know in terms of mixed numbers. I enjoyed the roots being in there. That was a really good revision of roots. And the basic theme of this whole idea is divide into terms, simplify each term, move from left to right. And I said left, let me add in a T there, left to right. Most importantly, if you're looking at one term that's quite complicated, always simplify your roots and your brackets first. And hopefully it's not actually too bad. Most importantly, divide into terms. Okay, well done guys.